Okay, so for this problem, we were given example 2a10, and we're asked to find omega AB and omega BD. So first we want to find the instant centers of all of the links. So we have to find the velocity. So the velocity at A will be in this direction, and the velocity at D will be in this direction. And then their instant centers will be perpendicular each way of the velocities. And then from this, we conclude that the instant center of link AB is infinity. And then since links DB and AO are connected to fixed points, the instant center for BD is point D, and the instant center for OA is point O. Now with this in mind, we must first find the velocity at A. So VA equals VO plus omega OA crossed with the position vector, which is R of AO. And this will give us 0 plus omega OA in the k-hat direction, and we're going to cross that with the position vector, which is L in the I-hat direction. And this will give us VA equals omega OA times L in the j-hat direction. Now we have to find VB, and we can do that two ways. So for the first way, VB equals VA plus omega AB. Cross that with the position vector RB/A. And this will give us omega OA L in the j-hat direction, which is VA that we just found. And we're going to add omega AB in the k-hat direction, cross that with B, which we defined as a square root of D squared plus L squared, and that'll be in the I-hat direction, plus D, which is this height here, in the j-hat direction. So we'll get VB equals omega OA L in the j-hat direction plus omega AB times length B in the j-hat direction minus omega AB times D in the I-hat direction. Now we can also find the velocity of B using point D, as shown here. So VB equals VD plus omega BD crossed with the position vector RB/D. And this will be equal to 0 because this instant center is not moving, plus omega BD k-hat direction crossed with negative Li. And this will result in VB equaling negative omega BD L in the j-hat direction.
When solving, VB is equal to VB. So omega OA L j-hat plus omega AB times B j-hat minus omega AB times D in I-hat is equal to negative omega BD times L in the j-hat direction. And when solving for I and j, I is equal to negative omega AB times D, which is equal to 0. So omega AB is equal to 0. And then solving in the j hat direction, omega OA times L plus omega AB times B is equal to negative omega BD times L. These L's will cancel, and then as we saw here, omega AB is equal to 0. So this is equal to 0. So omega BD is equal to negative omega OA in the k hat direction. And negative omega OA in the k hat direction is also equal to negative 3 rads per second.